Okay, trig identities. So these are super fun. Pull out some paper, take some notes. If you printed out the notes, this is what we're going through. So let's just get going. A trig identity, or a trigonometric identity, is an equation involving trig functions that is true for all values of which the expression in the equation is defined. So basically it's saying like you could plug in whatever value and it will always be true. Okay. The identities help to evaluate functions, simplify expression, prove identities, and solve equations. Now, these are important once you get into calculus, okay? And especially the ones that we're going over today. Okay, so these basic ones are ones you definitely should know right now, okay? So sine, cosine, tangent, sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent is opposite over adjacent, okay? We know all of those. Now, we can get our first identity by dividing sine and cosine. Okay, sine divided by cosine ends up being tangent because, here, I'm going to just write this out. So if we have sine over cosine, we have this opposite over hypotenuse divided by adjacent over hypotenuse. Now, it's a little bit easier for me to write this like this. So opposite over hypotenuse divided by adjacent over hypotenuse. Well, we can flip and multiply that. So that's opposite over hypotenuse times hypotenuse over adjacent. Those cancel, and I'm left with opposite over adjacent, which is tangent right there. Okay, so that's where we get tangent from, and that's why tangent equals sine over cosine. This is the first big thing that we need to remember. Okay, another big thing with this is that the cosine of theta can't equal 0. Okay, so like cosine couldn't be 90 degrees. Because the cosine at 90 degrees is 0. Because 90 degrees, remember on the unit circle, it's your x value. And the x value there is 0. Okay? So that's our first trig identity. Now the second one, or the other ones, cosecant, secant, cotangent, those are the reciprocals. So we just flip them. Since they're reciprocals, we can write, let's look at this part right here. We can write them. Cosecant is the same as 1 over sine. Secant is the same as 1 over cosine. Cotangent is the same as 1 over tangent. Okay? And vice versa. You could go backwards. There's no reason really why you'd ever do this. You just need to like recognize it. So in some proof or something, if you had 1 over cosecant of theta, you'd need to know that, oh, that just equals sine of theta. Okay, so these ones right here are also important. And then with that, and the same logic that we did to get this, cotangent is the same as cosine over sine. Okay? So these are all written, and just remember when you divide, you can't ever divide by 0. So that means like on that first one, cosecant can't equal 0, and secant can't equal 0, cotangent, blah, 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 and so on. Okay, so there are those first identities there. Okay, I would always use these two right here before I use these two. Okay, always use these two because it puts it in terms of sine and cosine versus these ones. Okay, we always write this down, want to work in terms of sine and cosine versus the other identities. If you work in terms of sine and cosine, it usually will break down easier for you. Okay, and I'll get more into that in a second. Now here, we have the Pythagorean identities. Okay, so Pythagoras came up with the a squared plus b squared equals c squared. And we can use this logic to find our first Pythagorean identity. So I'm just going to divide this all by c squared so that I get it equal to 1. So that's the same as a over c squared plus b over c squared equals 1 squared. Okay, because if you have like this right here, since both of these are squared, I can just write it like that. Same thing here, those cancel out, leaving us with 1. Okay? Now, let's put theta right there where Pythagoras is standing. And from that angle, sine is opposite over hypotenuse. So the opposite side is A, hypotenuse is C. And then cosine is B over C. Well, it looks like we have an A over C and we have a B over C here. So that's going to be sine of theta squared plus cosine of theta squared equals 1. And a way to write this is just standard across the board when it comes to identities. But that's just comes to trig. If you're going to square like the sine of something, you can just put the squared before it. So sine squared of theta plus cosine squared of theta equals 1. This is our first Pythagorean identity. Okay, and this is a big one. You need to remember this one. And it's super easy. It shouldn't be hard. Sine squared plus cosine squared equals 1. You should be able to remember that. That needs to be drilled into your brain, like tattoo it onto your hand or something. I'm just kidding. Please don't tattoo it onto your hand. Like your parents would be like, what the heck is your math teacher telling you to do? Like, yeah, don't do that. But anyways. So from this, we can get the other two identities. Okay? So first, let's divide out that cosine squared of theta. So now we have sine squared over cosine squared. Well, sine over cosine is tangent, so that becomes tangent squared of theta. This cancels and just becomes 1. And then 1 over cosine is secant. So tangent squared plus 1 equals secant squared of theta. That is our second Pythagorean identity. Okay, and again, we can get the third one. But now instead of dividing by cosine, let's divide by sine. So let's divide by sine, squared of theta. Well, this cancels, leaving us with 1. Cosine over sine is cotangent. And then 1 over sine is cosecant. Cool. So that is our last one. Okay. You need to have these drilled into your mind. And remember, you don't necessarily need to memorize them. You can derive them. Okay, this is why I showed you how to derive them, because I remember things better when it's like, well, this is where it comes from, versus like, no, just memorize it. Okay, and like, don't get me wrong, there are going to be a couple things in this unit that I'm like, well, just memorize this, or like, you're going to get the paper for this, you know, but like these ones right here, you have to memorize these ones. Okay. Here's a little meme to help you. I wish I were sine squared and you were cosine squared, so together we could be 1. Isn't that so cute? Like, I told my boyfriend that and he didn't even know what I was talking about. I'm just kidding. But anyways, so here are the identities that we're going to be working with right now. Okay, so we have the quotient identities. That's the tangent is sine over cosine. Cotangent is cosine over sine, other reciprocals, and then the Pythagorean ones that we just went through. Cool? Okay, so from this first one, we can rearrange that so we can technically get 3 more. I could subtract that sine squared over and you get cosine squared of theta equals 1 minus sine squared. Or I could subtract the cosine over and get sine squared equals 1 minus cosine squared. We can do the same thing here, which tangent squared would equal secant squared minus 1, or 1 equals secant squared minus tangent squared. Same thing with this last one, cotangent squared equals cosecant squared minus 1, or 1 equals cosecant squared minus cotangent squared. Okay, so really there's like 9 of them there, but you need the 1 and you can derive all the rest of those. Okay? Blah, blah, blah. To simplify a trig expression means to rewrite it as a numerical expression or in terms of a single trig function if possible. Okay, so we are going to use some strategies here. First, you want to rewrite using reciprocal and quotient identities. That means get everything in terms of sine and cosine. Okay, if you get everything in terms of sine and cosine, things will start to fall into place a little bit easier. And then look for Pythagorean identities or a possible way to create one. Okay. And then there's our identities. Let's just pull those up. So let's look at this first one. So we have secant of theta minus sine of theta times tangent of theta. Let's get everything in terms of sine and cosine. So secant is 1 over cosine. It's right here. Okay, and tangent is sine over cosine. So let's write this in terms of that. And I'm not going to change the sign. So that's 1 over cosine minus sine of theta times sine of theta over cosine. Now I can put that sine of theta over 1. It makes it a little bit easier, and then just multiply straight across right there. So we have 1 over cosine minus sine squared of theta over cosine. Since we have a common denominator, remember if you had like 2/7 plus 1/7, we have that common denominator there, it would just be 3/7. This is the same idea, okay, same exact thing. So here, that's just going to be 1 minus sine squared of theta over cosine. Well, 1 minus sine squared of theta, if we look down at our Pythagorean identities, that is cosine squared of theta. So this is cosine squared of theta over cosine, which then cosine squared of theta is the same as cosine times cosine over cosine. Well, if you divide by something that's the same on top and bottom, they cancel. So all we're left with is cosine of theta. Okay, so that means this thing right here is the same as cosine of theta. And you could test that, like if you had a calculator that you could put secant in, and technically you can, like if you want to test it in your calculator, you could do like 1 over cosine of 45, because remember secant's the same as 1 over cosine, minus sine of 45 times tangent of 45. And you should get the same exact thing as if you were just to do cosine of 45. Okay, kind of cool. Let's look at this one. So sine of A plus cosine of A times tangent of A. Again, start with getting everything in terms of sine and cosine. So we are just going to use that right there. So that means that the sine of A is not going to change, cosine of A is not going to change, but tangent, let's change it to sine over cosine. Again, we can just put that over 1 and multiply straight across. When you multiply, we have a cosine on top and bottom, so they just cancel. So we have sine of A plus sine of A, which if you add two things that are the same, like if we had x plus x, that would equal 2x. Same thing here. If we have sine of A plus sine of A, that equals 2 sine of A. Okay, let's do this one. So 1 minus sine squared of theta over tangent squared of theta. Again, start by getting this in terms of sine and cosine. So fractions aren't super cool though, so before we do that, let's just rewrite this as a division problem. Okay, sometimes, anytime you have a fraction, actually, if it starts as a fraction, rewrite it as a division problem, and it will help to, it just is a little bit easier. Okay, so tangent, now let's get it in terms of sine and cosine. Tangent is sine over cosine, so that means tangent squared of theta must be sine squared over cosine squared. Okay, so here this is going to be 1 minus sine squared of theta divided by sine squared of theta over cosine squared of theta. Now remember, when you divide by a fraction, you have to just flip it and multiply. So we can flip that second fraction and it becomes 1 minus sine squared of theta times cosine squared of theta over sine squared of theta. Put that over 1. Those sine squareds cancel. So I'm left with 1 minus cosine squared of theta, which if you look down at your Pythagorean identities, that's the same. Or sorry, I've been saying theta, x, whatever. It's just a variable, but that equals sine squared of x. Okay, so this equals that. It's just a simpler way of writing it. Okay. Let's do another one. So 3 minus 3 cosine squared of theta over sine of theta. Well, on top, we can factor a 3 out of there. Okay, so I can factor a 3 out, and I'm left with 1 minus cosine squared of theta over sine of theta. Well, 1 minus cosine squared of theta is sine squared of theta, so that's 3 sine squared of theta over sine of theta. One way that kind of helps me, and I think it'll help you guys, if you write out that sine squared as sine times sine, well then those signs cancel and we're left with 3 sine of theta. Okay. Okay, let's do these ones. Remember, again, don't like those fractions. Let's create these into division problems. So that's the same as sine squared of alpha, that little like A looking thing is called alpha, divided by tangent squared of alpha, plus tangent squared of alpha divided by secant squared of alpha. Change everything to sines and cosines. That should always be your go-to. Like, if you're like, I have no idea what to do, and you haven't changed things to sines and cosines yet, like, that's what you need to do. So tangent is sine over cosine. Secant is 1 over cosine. So we can change this sine squared of alpha divided by sine squared of alpha over cosine squared of alpha, plus sine squared over cosine squared divided by 1 over cosine squared. Division, flip and multiply. So that's sine squared of alpha times cosine squared over sine squared, plus sine squared over cosine squared times cosine squared over 1. Now I can put that sine over 1 to kind of help here. And we can see that those sines cancel and the cosines also cancel. So that means cosine squared of alpha plus sine squared of alpha. Well, this is the very first, very basic, very most important Pythagorean identity. That equals 1. So whatever we plug in for alpha, like you could say that alpha equals 100, and you'll always get 1 out when you plug it into this specific starting equation. Okay, or expression, it's not an equation. Remember, expressions don't have equal signs. Equations have equal signs. That's the difference between the two. Okay, this one, change everything to sines and cosines. And cotangent, I would always use this one over this one. Always, 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 always. And same thing, use this one over this one. Okay, so cotangent is cosine over sine minus cosecant squared of theta is 1 over sine squared of theta. And then tangent is sine over cosine. Now I'm going to write that sine squared of theta as sine of theta times sine of theta, so I can see that, oh, those sines of thetas are going to cancel. So I'm left with cosine of x over sine of x minus 1 over sine of x times cosine of x. Well, let's get a common denominator. So think about, like, if we were doing like 3/7 minus 1/5. We'd have to get a common denominator to do this, right? We have to do the same thing here. We have to get a common denominator. They both have that sign in common. This one's just missing cosine. This one. Sorry, I like point and I know you can't see me. But this one's missing cosine, so you can multiply top and bottom by cosine of x. Get a common denominator, says Mr. Turtle. He's like a cowboy turtle, you know, like, and that's a fake gun. It's like a squirt gun, you know. He's going to squirt you with water if you don't get a common denominator. So we're going to multiply that by cosine over cosine. We end up with cosine squared of theta over x, cosine of x, minus 1 over sine of x, cosine of x. So that's cosine squared of x minus 1 over sine of x, cosine of x. Well, now it looks like we have this sine squared of theta equals 1 minus cosine squared of theta. And this is super, super close to what we have here, except the signs are off. So let's just try and get those signs the same. Let's multiply everything there by -1. So then we get negative sine of squared of theta equals -1 plus cosine squared of theta, which is the same thing if you just switch that order. So that means cosine squared of x minus 1 is the same as negative sine squared of x. And then that's over sine of x, cosine of x. I can rewrite that sine squared as sine of x, so those signs cancel. I'm left with negative sine of x over cosine of x. Well, sine over cosine is tangent, so that's a negative tangent of x. Cool. Oh yeah, and here's Drake. Like, it's not, see, Titanic, but if you do sine over cosine is tan, or tan. Yeah, whatever. You get it, but like, yeah. Okay, I think that's all. Sweet. So, yep, good luck on your homework. Goodbye.